All right, so on Thursday or whatever, we did power functions. And if you put a whole bunch of power functions together, you get a polynomial function. So if you have something that looks something like this, that's a polynomial. All right, in a polynomial, poly means many, and nomial means something. Many numbers, great. Many terms. Oh, good. Many names, many terms. So a polynomial has many terms. Okay, and this is the form of a polynomial function. And let's see, we call like all these out in front are called our coefficients. Does that sound familiar from maybe Algebra 2? We usually keep them in good housekeeping order where we arrange the exponents in descending order. And we call this our leading term. Okay, the first term is the leading term, and it can tell us a lot of information. And things that we generally like to find out about polynomials are things like where are the zeros? ES or just S? ES. Yeah, I don't know if that looks right. Just S? ES? Okay. Danny Brown. Zeros. Long-term behavior. And long-term behavior means what's the limit as x gets really big, and what's the limit as x gets negatively really big. That's what we mean by long-term behavior. Hey, when x goes out to infinity, does the function get big or small? Or when x goes out to negative infinity, does the function get big or small? Mins, maxes. Sometimes we call these extrema. Mins and maxes collectively we call extrema. What else do we like to know about polynomial functions? I think that might be it. If I think of something else, I'll be sure to tell you. So, given that, and given our classwork, maybe we can take a look at maybe we can take a look at 8, and then maybe we'll go back to do 7 and 6. So let me give you, I'll do 8A. I'll give you about a minute. You can talk to someone if you want. You can do it however you want. There should be at least a couple ways that we should think of for doing 8A. Hey, look who it is. All right, so going back to the notes we just looked at on polynomials, we talk about mins and maxes, which we often call extrema. And Keith, you're not listening again. My goodness. Extrema, that's what we call mins and maxes. All right, so if we go back and we take a look at A, we want to determine where the zeros are and where the extrema are. And someone asked, can we use our calculator? And the answer is sure. The other question is, do you need your calculator? And I don't know. Maybe the answer is yes, maybe it's no. What do we have? How do we go about finding the zeros for this function? Travis?
You can graph it.
All right, so you can graph it to find the zeros. And what'd you find for your zeros?
2, 6, 0, and 3.73.
All right. Do people agree with that using their calculator? It seems to me that those are the answers you got. That A, what might be your first inclination for A to find zeros?
0.
Yeah, keep going. What? Say factoring. So you factor the 3 out, and then you try to factor it, and it just doesn't work. Not very easily, right? If factoring doesn't work, what else can you do for? Yeah. You can complete the square, which is actually gets us to the place where Elizabeth says it leads to the quadratic formula. So you can use the quadratic formula to get the exact values for those zeros. Negative b plus or minus the square root of b squared, 144 minus 4 times a times c, so that's 36. So 144 minus 36 is 108. All right, thanks. All over 2a, which is 6. So if you actually did that on a calculator, you would get about 0.26 and about 3.37. Okay, so the quadratic formula is amazing because it will factor any quadratic polynomial. It doesn't do anything more than quadratics, though. Okay, and what if we want to find the extrema? How do we go about finding the extrema? First of all, I have a question for you. Does A have a minimum or a maximum? It only has one. Why a minimum, Monty? It is a parabola. Why it doesn't have a maximum, though? Go ahead. I'm talking to you, Monty. Oh, all right. I thought you were raising your hand again. Oh, you're all right. Fine. Pick someone to pass off to. Sorry, I didn't get that. The fake pass. I like it.
It's a parabola, and it goes on forever.
Why can't it be a maximum? How do you know? All right, the leading coefficient's positive, so that's a parabola. It's opening up, okay? Since it's opening upward, I know it's going to have a minimum. All right, how do we find the minimum?
Vertex.
Keep talking.
Negative b over 2a.
All right, so you could do negative b over 2a, which is 12 over 2 times 12 over 6, which is at x equals 2. Is that all right?
Yes.
All right. If you didn't want to do vertex, negative b over 2a, which I like, I'm really glad you remembered that, you could use your calculator, and if you use your calculator, you can do calc min, and you'll get x equals 2, and you'll get the value. Is that okay? Say yes.
Yeah.
Okay. I was just thinking, I forgot to tell you this. For a polynomial, n has to be a positive integer. I did not mention that when I was talking about the definition of a polynomial. So it has to be like, it can't be x to the 1.2. It's got to be 1, 2, 3, 4, 5, so on. And it can't be negative. So we're not talking about x to the negative 2. If we're talking about x to the negative 2, now we're talking about rational functions instead of polynomial functions. So polynomial function, n is a positive integer. All right, let's take a look at b. If I want to find the zeros to b, let's see if we can do it by hand. How do I do it algebraically? All right, hold on, let me catch up with you. Set it equal to 0, factor out an x, and I get x to the 4th minus x squared minus 6 equals 0. I'm going to see if it factors. What x to the 4th, if I was going to break that up into 2, all right, x squared, and then what are the factors of 6 that add or subtract to 1? 2 and 3, and now I have to figure out, is it going to be negative 3 positive 2 or positive 3 negative 2? Okay, so check this out. I think I have it. Either x equals 0, or x squared minus 3 equals 0, or x squared plus 2 equals 0. X equals 0, or x equals plus or minus root 3. What about this? X squared plus 2 equals 0?
That doesn't work.
No, it doesn't. Those are imaginary roots. So this function, x squared, x to the 5th minus x cubed minus 6x, has a 0 at 0 and at plus or minus root 3. Let's see. All right. If you have like x squared, that's going to have one turning point. It turns from going down to up or from up to down. X cubed is going to have 2 turning points. Right? So it turns from going up to down or down to up, or I should say mins or maxes. It has two mins or maxes. Just so you know, though, let's see, there's x squared. X cubed, something x cubed, a polynomial x cubed could also look like this. Does that have any mins or maxes? But it could have at most two. And actually, if you take the leading coefficient, the leading term, like x to the fifth, the most number of mins or maxes it could have is 4. It's always one less than the power, the leading power. The most numbers of zeros it could have would be 5. So if you had x to the fifth could look like this. Let's see if I can get it right. There we go. Sorry, I ran out of room a little bit. X to the fifth could look like that. It could have 1, 2, 3, 4 zeros, and it could have, 5 zeros, and it could have 1, 2, 3, 4 mins or maxes. Evan?
How are those mins or maxes if it goes on infinitely up and down?
You're absolutely right. And I will go back and I will change that to local extrema. And that's a great thing to talk about. This is a minimum in its neighborhood. So if you're just to look in the neighborhood, it's a minimum. So we call that a local extrema or a local minimum or maximum. However, Evan's saying, yeah, but look, if you look over here, there are points that are much less than that point. Much less than that. So we would say that this function, although it has a local minimum here and a local minimum here, it has no global minimum. There's no such thing as being the absolute least number because there's always something that's less than it. Okay? And that's actually, whenever you have an odd function, your odd function is not going to have any global mins or maxes. It won't have local mins or maxes. Okay? That was a nice comment to make. Thanks for making it. All right. I think I'll put a halt there, hand out some stuff.